This question asks, the position of a moving particle is given by s of t equals 2t cubed minus 18t squared plus 48t plus 67. The particle is moving in feet where east is positive direction and t is measured in minutes. Keep in mind that time can only be positive after start. Let's look at A. Find the first and second derivative of s of t. So let's find the derivative of this, first and second derivative of that. First derivative will be 6t cubed minus 36t plus 48. Our second derivative will be 12t minus 36. B asks, if the first derivative is the velocity equation, when does the particle at rest? Basically, for this one, we set our first derivative equation equal to 0. So 6t squared minus 36t plus 48, set it to 0. To make this easier on us, let's take out the 6. It would be t squared minus 6t plus 8. This factors out to t minus 4 and t minus 2. So t equal to 0. We'll have t equals 4 and t equals 2. So the particle is at rest at t equals 4 and t equals 2. C asks, algebraically, determine the intervals where s of t is increasing. So for this, we will be looking at the intervals for velocity. And since we already found particles at rest, which is 4 and 2, we'll be using those. For this, we plug in specific numbers between our intervals to find if they're positive or negative. So we could plug in V1 for this. We plug in 1 to this right here. We will know that that will give us positive. You could plug in 3 for this interval, between these intervals. You plug in 3 here. That will give us negative. Plug in 5. Again, plug it into here. That will get us positive. So because of that, we know that s of t is increasing on the intervals 0, 2, 4, 2, infinity. And we know this because of these two positive values. D asked, on which intervals of time does the particle moving west direction? So we know the particle is moving in the west direction from 2 to 4. If we look back into our original question up here, it mentions that the particle is moving in feet where east is positive direction. So that must mean west is the negative direction. And if we go to our intervals, negative is between 2 to 4. So the particle is moving in the west direction on 2 to 4. Our next question asks, on what intervals of time does the particle have negative acceleration? So this time we're setting our second derivative to 0. So let's start with that. 12t minus 36 equals 0. 12t equals 36, put 36 to the right side. Divide each side by 12 and we get t equals 3. We use this to help make our number line for our acceleration. Now let's plug in numbers for our intervals. Let's plug in 2. We plug in 2 to this. 2 will get us negative. Let's plug in 4. Again, plug it into this equation. This will get us positive. So we know that the particle has a negative acceleration on 0, 3. Because between 0 and 3, we have a negative. Okay. Our next question asks, using the information from A to E, determine the time intervals when the particle is slowing down. Now, for this one, we use both our velocity and acceleration. So let's make the lines. V of t, A of t. So luckily we've already made them. So for velocity, we have u4, acceleration, just have 3. Our intervals were positive, negative, positive for our velocity. Positive, negative, positive. And for our acceleration, we have negative, positive. Now from this, we could say that the particle is slowing down on 0 to 2 and 3 to 4. And we know this because based off of our signs, if we have the same signs, then that means it's speeding up. If we have different signs, then it's slowing down. So the particle is slowing down on 0, 2 and 3, 4. And with that, those are answers for these questions.